I'm honored to welcome you to our third and final UCR Brain Game Center lecture on memory by the center's director, Professor Aaron Seitz. Professor Seitz earned his BA in Theoretical Mathematics from Reed College, his PhD in Computational Neuroscience from Boston University, and conducted his postdoctoral work in Systems Neuroscience at Harvard Medical School. He was also a research assistant professor at Boston University before coming to UC Riverside in 2008. While his primary appointment is in psychology, he holds cooperative appointments in bioengineering, biomedical sciences, computer science, the interdisciplinary neuroscience program, and psychiatry. He is director of the UCR Aging Initiative and director of the UCR Brain Game Center. These important lectures are co-sponsored by the UCR Palm Desert Center and the College of Humanities, Arts, and Social Sciences at UC Riverside. This evening, we would like to thank the UCR Palm Desert Center partners for their meaningful support of our programming. Also, we would like to especially acknowledge Bob and Cheryl Fay for their continuing generosity in supporting programming at UCR Palm Desert Center, as well as their work with the Brain Game Center. Additionally, we at UCR would like to respectfully acknowledge and recognize our responsibility to the original and current caretakers of this land, water, and air, the Cahuilla, Tongva, Luiseno, and Serrano peoples, and all of their ancestors and descendants, past, present, and future. Today, this meeting place is home to many indigenous peoples from all over the world, including UCR faculty, students, and staff, and we are very grateful to have the opportunity to live and work on these homelands. Before introducing Professor Seitz, I'd like to share with you the format of tonight's one-hour program. Professor Seitz will offer his lecture, and during that time, you're invited to enter any questions you have in the Q&A. Following the lecture, we'll have a brief Q&A. Those questions we can't answer in the course of the program, Professor Seitz will be happy to respond to via email. And now, Professor Aaron Seitz.
Thanks. Let me just get screen sharing going. Great. Hopefully you can now all see my screen. So tonight I'm going to talk about memory. And as a reminder for some of you, this is part of a series that I've given where the first talk I talked about vision, then hearing, and then culminating this talk in memory. And so I'll review these a little bit at the end, and they're all available online if you miss some of them. And the topic of this series has been this topic of brain training. And so these slides that are kind of showing pictures of brains, running on treadmills or lifting weights, is supposed to kind of give an analogy with physical exercise. And that the idea is that as we learned about the cardiovascular system and muscle physiology over the last century, we were able to develop training approaches for the body that have made it so people could run faster, jump higher, be more endurant, and generally be better athletes. With the brain, we've had a lot of advances in psychology and neuroscience, and that this gives rise to a similar opportunity of, can we take advantage of this knowledge to be able to come up with brain fitness approaches that will also be able to help with our vision, our hearing, our memory, and other aspects of what our brain does. And this really is the focus of the UCR Brain Game Center for Mental Fitness and Wellbeing that I created. And this slide just gives a touch of kind of how we think about essentially everything that we do, from basic, perception to language skills, emotional regulation, happiness, well-being. They're all the result of brain circuits functioning well. And so what we really try to do at the Brain Game Center is do kind of principled research to try to translate what we know from psychology and neuroscience, to design, test, and disseminate evidence-based approaches that some of them are focused on measurement to understand brain functions, and then others are focused on training to be able to better these, all with the goal of having relevance to real life activities. And so one challenge that has been really apparent over the last few decades is really, how do you take the knowledge that we gain from laboratory studies and have it have utility that will benefit people in the real world? The topic for tonight really is, how are we able to train memory? And memory is something that everybody, especially over their lifetime, becomes less satisfied with. And so, I'll show you some graphs of this in a moment, but, as we get older, basic challenges of remembering people's names, where do you park your car, what to get at the store, are daily nuisances. And then as memory loss becomes severe, then it can really have serious impacts to people's lives. And one thing which is really, I think, somewhat frustrating is that if you go to a doctor and you say that your memory is not what it used to be and that you want to know kind of how to improve it, they'll typically say, well, you're just getting older. And that the reason for this is that there really are not universally accepted approaches to improve memory. It makes sense in that we're much better at treating mechanical aspects of the body than functions of the brain. But at the same time, it gives rise to a substantial unmet need. And one way that myself and other people in my research field are trying to address this is looking at different ways to train memory. And one area of memory that I'll focus on a bit tonight is what's called working memory. And so working memory refers to essentially your ability to store some information in your mind and to be able to process this, update it, maintain it for a period of time. And so, for instance, if you're doing a math problem, to the extent that you're manipulating the numbers in your head, that's using working memory. The common test of working memory is that you are given a list of words and then you're asked to repeat them immediately afterwards. And so working memory is defined that it's short in duration. So we're typically talking about just how you memorize things over a few seconds. But what's interesting about it is it's really a gateway to all other aspects of memory, because anything that goes into long-term memory typically is first processed in working memory. And so if working memory doesn't process it well, then it's unlikely you'll remember it afterwards. And then anything that you recover from long-term memory also has to go into working memory for you to be able to process it. And so this makes it a very interesting target for people who are trying to look for memory improvement. And then if you look at memory as a function of age, so on the left, you see long-term memory, in the middle, you see working memory. And what you see is that both of those decay substantially from when you're in your 20s. And so there's other graphs that I could also have shown that before your late teens and early 20s, it's also increasing. But that pretty much for everybody, our memory is not really getting any better. On the other hand, there's some things that do get better. So what's often referred to as crystallized intelligence. So vocabulary, the number of facts that you know, things of that sort. Those things do increase, across your entire lifespan. And so, there's definitely a disconnect between the types of cognitive skills that we use to be able to kind of navigate the world, like working memory, and the knowledge that we are gaining across our lifespan. And so with working memory, what's been really interesting is that there are increasing numbers of training programs, many of them computerized, And they're being used from kids to older adults to people who are generally healthy to people who have different types of neurological disorders or mental health issues. And that, I'm showing you the bottom left is actually a picture of a game recall that we made. The bottom right is a picture from Lumosity that has a working memory training. And what's nice about these training programs is that this is showing data from a group of older adults. They were, I think, age 60 to 80 in this study, and that they're training across 20 different days on these working memory tasks. And what you could see is that the graphs go up. And so, for the verbal stimuli, so these are, a series of letters that you have to remember. This moved from a little bit below 4 to around 5.5 on average. And then spatial, your ability to remember kind of a series of dots appearing at a different location on the screen, increased a bit as well. And so this is encouraging in that there's, good evidence that not only have we identified a kind of core aspect of our brain's memory processes, but there's good evidence that with training that this can improve. And of note, when you look at that verbal working memory skill, so that's something, if you look at college students, typically they'll have a score around 6 or so. And so you're actually getting to, typical, peak levels of working memory as a result of this training. However, something that I brought up in my previous talks, and I think it's really important to repeat now, is this issue of specificity to what is being trained. And so here I'm showing you an example of a standard working memory training task. And so this one is called the NBAC. And so in the NBAC task, what you could see is that there's a series of grids. So this is actually one of those spatial working memory tasks I referred to. And so with each grid, hopefully you can see my cursor, you see that there's a blue square presented at a different location. And so first you'd see it with the one at the bottom right, then you have another one at the bottom left, and then this third one shows the bottom right again. And in the case of a 2-back, the task is you're supposed to say whether this matches what you saw 2 items ago. And so in this case, the third one's a match. Then the fourth one's not a match because it's different from what we had 2 items ago. The fifth one is not a match, and the sixth one is a match again. And so the way that this training would typically start is that you would start with the 2-back, and if you did pretty well on that, then you would have to do it 3 items ago. So did this match where you saw 3 items ago, then 4, then 5, then 6. And so that's where you get this data like I'm just showing you here in terms of the change in performance across training. The reason I bring up this issue of specificity is that what happens when you go to the grocery store, you're trying to remember what's on your shopping list, and that it might not transfer to that. And there's this big concern of when is it that you're just teaching to the test and so that you're getting better at the training activity, but it's not necessarily going to help you when you go about your daily activities? And when is it actually transferring to or generalizing to other activities beyond what's being trained? And so one thing that has been really interesting, and this is some data from my colleague Susan Yacke, who's at UC Irvine, is that this is now showing data from a group of college students who is trained on the NBAC task. And this graph on the bottom left that says task learning is just showing that now here the college students start off around the 3-back, so they could match what was seen 3 items ago. And then after about 20 days of training, they get about to the 5-back. So a fair amount of improvement. But in this group, they also found that there's an improvement in fluid intelligence. And so this is basically a standard IQ test that was given, but not for a group that was just doing knowledge builder problems. where they're basically doing trivia kind of the same number of days as the other group that did the working memory training task. And so this is the type of thing that has gotten people excited, because here's an example where we train on a working memory task and we get transferred to an IQ task. And so the problem, though, is that the results differ across studies. And so about half the studies that have been done with this working memory training have shown transfer outside the training domain. And then about the other half haven't. And that researchers in my field debate heavily the extent to which working memory training is effective or not, based upon these discrepancies that you find in the literature. And so I'm about to show you, so this graph is about the most complicated plot that I could show in a talk. And the reason I'm showing this to you is that I want to explain a basic problem that we have in the field. And so what this plot is showing is a review that we did of 51 different studies that trained on this NBAC task. And what we're showing with these different colors are all the different things that they did. So the way to kind of track this is that each of these numbers on the outside is referring to one of those studies. And so then each of kind of the radii is basically showing 10 different things that we identified about the studies that differed. And so the ones that are in the first 6 of the rings are different things that people trained on. So some of the times they were doing a NBAC task where you're just doing it on one stimulus, let's say auditory or visual. Some of the time you were doing 2 at the same time. Some of the time it was gamified. Some of the training was spatial, like I showed you with the grids. Some was visual or verbal. Some was auditory. And then sometimes you got feedback. And then basically a bunch of different things would vary across the training. And when we started looking at how many studies actually trained the same thing, only 7 of the studies were actually doing the same training. And so that's what you could see with all the different colors, that these are not comparisons of the same type of intervention. People are doing different interventions. And then what you see in the colors on the outside rings, where there's maybe a little bit more regularity, but there's still a lot of differences, is that when people tested the outcomes, that there were a bunch of different working memory tasks that people tested to see whether it transferred to. And in fact, there are about 30 different working memory tasks across all the different studies. And then for the people looking whether there was a transfer to fluid intelligence or IQ tests, there are about 30 different types of IQ tests that people used as well. And so the problem that we have here is that every study is using different methods, both in terms of what they're training and in terms of what they're testing for outcomes. And so this makes it extremely difficult to make any conclusions, because when we start looking at the half of the people who found positive results and half the people found negative results, since they weren't training the same things and they weren't testing the same things, it puts us in a situation where we actually cannot make very strong conclusions. And so this is one of the things that we're trying to address at the Brain Game Center. And so what we are doing as we're looking at this literature is that we're trying to identify what are the features that might differentiate a working memory training procedure that is going to be effective and one that might not be. And so some of the things that we look at are the diversity of stimuli that you experience in the training, because if you wanted to transfer to a wide set of things that you do in real life, maybe it doesn't make sense to only train on, let's say, where these colored squares are appearing on the screen, because lots of things that we're doing, involve very different stimuli than the spatial stimuli. The other thing is considering that working memory, it's used in lots of different tasks and in different ways. And so as a psychologist, we try to break this down into, one thing you have to do in working memory is that you have to update it. So you have to bring new things into your memory and release other things from your memory in consequence. There's capacity, the number of things you can remember at once. There's resolution. How well do you remember each item? Association. Can you learn relationships between items? And that if we wanted to transfer to daily activities that involve all these things, then maybe we need to train across these different domains of working memory. Other things we look at are the motivational framework. So, when does a game help? When does it hurt? What sort of feedback do you give to people or incentives? Something I'll talk about next is when you're designing these complex training tasks, how do you do it in such a way where when you add things that they improve the game as opposed to subtract from it? And then other things I think are really important is personalization, in that not everybody is the same. How do you make sure that the task adapts to the needs of the user? And then, as I also mentioned in the previous slide, we need to make sure that we use outcome measures that are meaningful and that ideally can relate to what people do in the world. And so I'll talk about a few of these. So the first one I want to talk about is this issue of design. And it's one that, when I first got into this field, I hadn't realized how complex it really was going to be. And so what I'll show you here, and this is actually another study from my colleague at UCI, Susan Yaki, where they developed a working memory training that they use for children. And so it kind of makes sense. If you're going to, have kids do this, well, you might want to make it look a little bit more interesting. And so they had this task where what you could see on the left is that the frog is appearing on different lily pads in the lake. And so they could do the same spatial task, but now themed. Or you have cats appearing at different windows in a haunted house, or monkeys appearing on different sails on a pirate ship. And then they looked at motivational features that would make this more fun for the kids, so that they'd get gold coins when they got correct answers. And they could use the gold coins to be able to get things from the prize box. In some cases, physical stickers at the end of the training. And they'd get certificates about their level. And so there's a bunch of different things that were placed into the training, all with the goal of trying to make it more fun and more motivating to the children. So the question is, did these things actually lead to better learning outcomes? And almost surprising is that what I'm showing you this graph is on the left, where the bar says all motivational features, and on the right, where it says no motivational features. And y-axis is the training gain. So basically, how much did the memory improve? What we find is that when you took out all the motivational features, everything that are supposed to make it more fun, the kids learn more than when all of them were present. And in fact, they also took them out one by one. And each time they removed one of the motivational features, performance improved. And I'll get to this, again in the next section, but one of the reasons this might have occurred is that these are distracting from the learning objective. So you could think about the kids, they get the gold coin. So they know they're going to be able to get a prize. So maybe they start thinking about what they could get, and that they forget that they're supposed to be doing the lesson. And so the lesson here is that, just making something into a fun game and adding elements isn't necessarily going to lead to improved learning objectives. And so these are some pictures of some of the games that we've created at the Brain Game Center that are focused on training memory. And so the top left is Recall the Game, where I'll probably show you a little navigation animation in a moment, but you're navigating a spaceship to try to collect targets of the task. Or the bottom left is similar to Remember Bee, where you're collecting flowers based upon your memory. Or what we're using today for a lot of our studies is this program called Recollect the Game or Recollect the Study, where you're navigating an astronaut and that you're collecting different items. And so these are also ones that are, visually complex, but we've been trying really hard to design the features so that your focus is maintained on the working memory tasks. And actually, I'll show you just a little bit of, how the recall game works. So you can see that here it's the same end back task, but now your spaceship is moving around the grid and collecting the targets based upon whether the color, the sound, the shape were consistent. And so this, it's definitely more engaging than the ones I showed you earlier. And then when we start looking at, does this game design kind of, as we spend time trying to make sure that people are focused properly on the task, solve this problem of, whether the added distraction hurts performance. We did a study where we took what we call the lane back sometimes, which is basically just an end back task where you're doing on the color of the circles. And of note, this is a task actually a lot of people enjoy because you are able to kind of see your memory improve as you move from the 2 back to the 3 back to the 4 back. The skin condition is one where it's similar to what I showed you with the child study, where basically we now embed the target, in this case, the colored gem, in a nice scene. But you're not navigating the character. You're still just identifying the attributes of that gem. And then the full game is one where you actually have to move the astronaut around and you pick up the gems that match the end back task and you avoid the ones that don't. And we're still working on this. And so these results might change with more data coming in. But what we're seeing in the orange is the skin condition, which is doing worse than a non-gamified condition. So this is replicating the study in children that basically showing that just creating a game by adding more visual details doesn't seem to be improving learning, at least on the training task. On the other hand, when we look at our full game, we're starting to see some evidence that maybe it even does better than a non-gamified task. Although in the next section, I'll tell you that, this might not be true for everybody. And so, actually I think my video just turned off. So let me just come back on. Okay, so hopefully I'm back. So the question here is, I'm showing you that, games, if properly designed, have some beneficial properties. But are they best for everyone? And kind of what I brought up a moment ago is that on one hand, games might be more visually appealing and more exciting. At the same time, they're distracting. And so that in order to be able to perform well, you need to be able to deal with multiple sources of information at once. And so one of the things that we've been looking at is the extent to which performance on the gamified task might differ between people who are good at being able to deal with all these distractions versus people who are more impaired by those distractions. And so the preliminary data that we have is that first, this is looking at training data. So what we do is we had a number of people who performed both a gamified and a non-gamified version of the MBAC task. And that we categorize them by whether their ability to what we call an inhibitory control, but be able to perform well in distracting environments, was relatively high or relatively low. And so we just kind of split people down the middle. What we see is the people who have poor ability to deal with distractors, that they did much worse with the game than non-gamified case. And in this case, the people who had higher inhibitory control skills, so better able to deal with distractors, they actually had similar performance between the non-game and the game. And so the other thing we look at is not just performance on the training task, but what happens if we test you on something that wasn't trained. And so in this case, this is just testing people on another NBAC task, but not the one that's trained. And what we see is that in blue versus red, so blue is after non-gamified training and red is after the game training, the people who had more difficulty dealing with distractors, they learned more with non-game than the game. And then the people who were better able to deal with distractors, they did a little bit better with the game than the non-game. And so the important observation here is that for some, the games are motivating. For others, they're distracting and confusing. And I'm sure that there's some people in the audience who, know this from personal experience. And like with me, I find that it depends on the game. So some of the games, work really well for me. And then other games that my kids play, it just amazes me that somebody can deal with, all those different things happening at the same time and enjoy it. And so the question is, so how are we building upon this? And that what we're currently doing is we recently launched a nationwide memory training study. And that what we're doing in this study is that we're trying to train 30,000 people on these working memory tests. And so this is a lot. I mean, and so far we've gotten maybe about 2,000 people to do this. And so if you're interested, I've shown the link. So you could just go to bgc.ucr.edu/train my memory. And this will be shared, I assume, in the chat. And what we're doing with this study is a little bit different than some other studies when people try to test whether intervention works, is that all the conditions that we have in this study are training on different types of working memory training methods that have been shown in some study to be beneficial to some people. But by running 30,000 people, what we're hoping to do is try to figure out which of these versions are beneficial to which people in what ways. So that we expect some people are going to do better with a gamified case. Other people will do better when it's not gamified. And then some people might have a good propensity to be able to get benefits from these working memory trainings. Other people, maybe not. And then the outcomes might also differ. So maybe some people, they'll do the working memory training and it'll help them with other working memory tasks. But maybe it doesn't transfer to things like test of fluid intelligence. But then for other people, it might. And what we really want to understand are these individual differences and just the different outcomes of the different training approaches in different people. And this, I think, is going to be really important to really serve people better, because instead of saying, here, I've created working memory training, I think it's good for everybody. It's ideally, take a set of tests, and then we could tell you the likelihood that different types of trainings will be beneficial or not to you. And I think that that would make a lot of people a lot more comfortable with these types of interventions. So just some discussion of the working memory training. It's something that has, I think, great potential as an intervention to improve memory. And there's lots of cases of people who have gotten benefits from these types of working memory trainings. At the same time, not all the training approaches are the same. And so if you look at different companies that are selling these products, that the way that they'll train working memory differs tremendously from each other. And then also not all people are the same. And so that, you know, just because you got a great benefit from one of these programs, maybe your friend isn't going to get a benefit from that. But maybe there's a different program that they would get a benefit from. And this is something that is important to solve. And the way to do this is to do studies like the one that I just advertised, is that we need to do more research in larger numbers of people across, you know, larger sets of different training approaches in order to be able to get to the outcome that I mentioned earlier of being able to personalize the training to different types of individuals. So with that, I just want to kind of review a little bit of the series. So, you know, I spoke about vision, hearing, and memory. I'll just give you one slide on each. So I start off with a talk on vision. And the main point I had in that talk was about how the eye and the brain works together to give rise to what you see. And that perceptual learning is the academic field that I grew up in, was really focused on how the brain can improve its ability to read out information from the eyes in order to be able to help you perceive better. And I showed an example of how we did a vision training study in the UC Riverside baseball team that actually led to them being able to have fewer strikeouts, hit more runs, and ultimately win more games. And that's actually how I got started in this field of kind of brain training, is that, you know, that gave me kind of the taste of what it's like to train somebody in the lab and then measure something that they're doing in their daily activity and see a benefit. Then with hearing, I spent a lot of time talking about this issue of the cocktail party problem, is that the complexity of how hard it is to be able to understand someone you're speaking to in a noisy environment where lots of other people are talking. And what I talked about a little bit is that one of the reasons this is complex is a lot of things have to go right for you to be able to do this. Because not only do you need to be able to differentiate different tones, like if you go get a hearing test with an audiologist, but you also need to be able to understand complex aspects of those tones that give rise to language. So that blue and red plot in the middle down here, if you could see my mouse, basically you could see that the frequency of meaningful sounds is changing across time in language or music or most things that we listen to. And not only that, but we could see in this other box is that this person needs to successfully solve the task of identifying where different sounds are coming from in order to be able to listen to the person that they want to and ignore the other people who are talking in the room. And so there also, I showed some data from an early stage training program where we started seeing some benefits to hearing in competing speech after training on stimuli that differed in the location they were coming from and how frequencies changed over time. And then the summary of the talk on memory is that, we have not just in my lab, but many other examples of training programs on computers that are trying to train memory, especially working memory. Almost all of them have the property that you'll get better on the task you're training on, which is something that feels good. But whether you remember, what you need to get when you go to the grocery store, or people's names, or the other things that are your daily memory challenges, it's not always going to be the case that it's going to be improved by these. And that to be able to really improve these trainings, and not just the memory ones, but we're also trying to do the same thing with the vision and the auditory trainings, is to collect a lot of data and a lot of different people, comparing different training approaches on common sets of outcomes, trying to understand individual differences, and then ultimately learn, what types of training might be good for which types of people. And so, I think that all of these cognitive brain training approaches really have a great amount of potential. I think the brain, we use this word plasticity, and that, we could shape it through experience. And that, it's definitely the case that we learn things across our entire lifespan. We learn new skills across our entire lifespan. But the approaches that are going to be best, are not fully discovered at this point. And the other thing is that the field to date hasn't focused as much on what I call the moderators and the mediators. And so the moderators are the individual differences, and the mediators are kind of the different training types that would give rise to different outcomes. And that really, to move forward, this is something that the field needs to tackle. It's going to require large data sets, and it's going to need to account for individual differences. And we need to be able to make comparisons across the studies, unlike that, colorful wheel graph that I showed you earlier. But if we could get this right, the tools really can help anyone. I mean, so when you look at, education or medicine or workplace settings, even just daily activities, they all involve many cognitive challenges. And that improving cognitive skills, not just in people who have, neurodegeneration with age or things of that sort, but, even like athletes in my baseball study, that everybody can get a benefit from the right types of training. And so this is what we try to do at the Brain Game Center. We are a research center, so everything I'm talking about is work in progress. I wish I could say that we solved the problems and here are our solutions, but we're researchers and we're working on it, and we'll update you as we learn more. And then, this is just a few people who have helped, particularly on the memory studies. So this picture of Susan Yaki, who I mentioned, who's my collaborator at UCI, who's part of this. Trevor Schroplis is the person who's been programming these. Anya Pahor and Rebecca Tuckerman are lead researchers in our projects. And then I encourage everybody to get involved with the Brain Game Center. We really need the community to work with us, and that we're also very interested to try to customize our approaches to the needs of people in the community. And so with that, thank you very much. I'll stop sharing so people could see me, and I'll take some questions.
Thank you so much, Aaron. We've got some terrific questions in the queue. We actually had one that was emailed this morning. I'm going to share that with us all first. Let me just pull that question up. That question is, what are the current recommendations for slowing down the effects of aging in the brain?
That's a great question. And it's something that the place where I've seen the most agreement is kind of learning a new thing every day. So there's lots of approaches like the working memory training that I showed, or the vision training, or the hearing training, or learning a new language, or learning to paint, or learning to sew. There's so many different activities that have some benefit. At the same time, what seems to be best is to take a new activity, learn it to the point where you're now good at it, and realize that once you're really good at it, it might not be helping you in the same way, and you learn something new. And so, for some people, it really is, every day learn a new thing. For other people, maybe it's every month learn a new thing, but keep on learning, and variety. And when you think about it, like I mentioned this issue where we don't know for a given person what's the right activity that might be best to improve their memory. But if you're trying different activities and going through multiple, the odds of coming up with the activity that is going to work best for you are also much higher. And it's also fun to try different things. And so we hope to get to the point where we could be more specific of, do exactly this thing and have exactly that result. But right now, keep on learning, have variety, and realize that once you've mastered something, that you probably need to pick up something new.
Great, thank you. Is working memory comparable to computer RAM, random access memory, and long-term memory as the hard drive?
I think it's a great analogy, although the amount of information that people can store in RAM, or computers can store in RAM, is much, much more than we could store in working memory. So like, depending upon what is being memorized, sometimes people say it's 7 plus or minus 2, or sometimes people say it's 3 to 5, but like there's a relatively small number of items we could keep in working memory well. And so on one hand, we're much more limited. On the other hand, it's really interesting in that the complexity of those items, can be quite high. And sometimes, exceeding the way that the computer would be representing them. But yeah, I think that's the, RAM versus, the hard disk is probably the easiest way to conceptualize it.
Thank you. Is the brain training available remote from home?
Yeah, so this is something that we've gotten a lot better with during the pandemic, is getting it so that our training approaches can be downloaded to your own tablet or smartphone. And so, for instance, if you sign up for the online working memory study, you never have to see us. You could basically do it all at home. And then we have some other studies that we'll do where we'll remotely administer the sessions. And so that you'll get on a Zoom call with us, and that we'll walk you through the procedures. And in some cases, we'll even loan you the equipment you need. So if you are interested, but you don't have a tablet computer that might be required, let's say for a vision or hearing study, please sign up, because we could drop one off and then pick it up afterwards. No contact delivery, so that, you don't actually, have to be in the same breathing space as somebody. So we're COVID friendly. But our goal really is to make the studies accessible.
Great. Is there any evidence that brain training can be used to improve emotional or other mental disorders, such as depression, anger, schizophrenia?
Yeah, there is. And it differs across these. So I think with depression, that's the one where I've seen some of the best results. And like even my vision training, I've seen positive effects in some individuals' depression. And I think that part of it is because of the incremental kind of reward structure, where like you could really see yourself getting better on the task. And that even though it might not be treating the underlying problems of depression, it can help you get out of a depressive state because you could feel personal accomplishment. There's some additional idea that it might be able to kind of strengthen some of the cognitive skills that would help with emotion regulation. And this is something that we're actively researching in our lab. But I don't have enough data to be able to state strongly the extent to which that is working as we hypothesize or not. And then with schizophrenia, we actually currently are doing a clinical trial with our vision training program in schizophrenia, where we're seeing benefits, at least in some individuals, not just in vision, but also in schizophrenic symptoms. And it's unclear, the extent to which that's similar to depression, where, it's helping them get from a bad state to a good state, or whether it's really addressing some core functions of schizophrenia. But there's a number of approaches that people have been trying that are kind of training combination of, both vision training and hearing training and working memory and executive function, with the idea if you could strengthen a lot of brain processes, that could be protective for people with schizophrenia and depression, or even cognitive reserve in older adults. And so this is some of the excitement, but the research is early. And that's the frustrating part, is that it's unclear which approaches will work for which people.
Wonderful, thank you for that. Is there any evidence that there's a difference between the way males and females memorize?
It's kind of unclear. I mean, there's definitely some studies that have looked at differences in the types of things that men and women remember, also differences in how men and women allocate attention. The extent to which those things are based upon men and women being neurologically different versus having kind of experienced different subcultures that have had them focus on different items of importance in their life is somewhat unclear. And so there's definitely, like, men and women are not the same, but it is very complicated to understand what are fundamental brain differences versus, what are things that people have learned across the lifespan that shape them differently.
Great, thank you. Can someone with dementia, mild cognitive impairment, benefit from brain games?
So that's one of the targets of these. At the same time, some of the brain games are somewhat complex. And so that I think that, there's a challenge of which of the brain games are accessible to people with dementia. And so the place where there have been the best signs of success are taking people before they develop dementia and using these types of brain games to be able to, once again, serve as a protective force to, delay the onset of dementia. And then once people develop dementia, it's much harder to intervene. Although I think there's future promise as we get better at this.
Great, thank you. And we have one last question. The percentage of people with hearing loss increases with age, and auditory training seems very important. Have you worked with audiologists to help people improve auditory skills?
So the hearing training that we're developing in collaboration with audiologists, in particular, Eric Gallen, who is at the VA Center of Excellence on Audiology. And we're right now in the phase where we're trying to move it from really the early stage kind of proof of principle studies that we've just completed to now we've been talking with a few different audiologists to start doing some pilot studies in the clinic. And so we hope to leverage those to, if successful, to be able to roll this out to more people. But, it takes a little bit of time to be able to, make sure that,
these work well, but that's definitely something that we're actively doing right now.
Great, thank you so much. So thank you, Aaron, for another tremendous program. Truly fascinating. We've had tremendous responses from our guests. Once again, we're very grateful to Bob and Cheryl Fay for their continued sponsorship of community programs at the Palm Desert Center, including the 2021 Brain Game Lecture Series. We also want to share with you their sponsorship opportunities, and I'm putting them into the chat so you have access to them, and I'll walk you through them very briefly. First of all, if you're interested in supporting future programs like these, please consider becoming a Palm Desert Center partner. We provided that link. The Brain Game Center Innovation Fund enables Dr. Seitz and his team to underwrite new ideas as they come up. I provided the link to that fund if you'd like to contribute. And if you're interested in sponsoring a Brain Game Center program in the coming academic year, please contact me, Clyde Derrick, and my email is provided, or my wonderful colleague, Rachel Polito, Director of Development. We're very grateful to all of you for your participation tonight. Thank you so much and have a pleasant evening.